And I did like the curves, but you just have to.
All right, we're rolling.
Any questions? Wow, that's a lot quicker than I was expecting. I have one.
Boy.
How come I have not seen as much stuff handed in or submitted as
Oh.
I would think would have been done by now?
I mean, I submitted like half of my stuff online.
Yeah, no, I mean, even including that. And if I look at master set 23, most people have it in, but not everyone. 24, even fewer.
Borrow one of these.
For the stapler?
Yeah.
Yeah. you can borrow one. Staple you can actually eat. I see why.
Just the labs do tonight, right?
Yeah, but I'm grading 24 and I've got 4 of them.
Yeah, cause isn't like 26 due next week?
Oh. I'll find.
Is this like a joke or you just didn't know?
I didn't know.
Oh, okay, okay.
Due on the 30th.
Like the end of this week, right?
I think it's the 30th, whenever that day is.
30th is Monday.
So I
Oh,
think-
okay, there we go.
So here's the big concern is that the test is on Monday and, and some people like wait till the last minute and some people, like my son, would have done the work and never handed it in.
Oh.
So, yeah, there's still no staples.
Oh, there are no staples, period.
Yeah, that was discovered a moment ago. I'll get staples in a moment.
No worries.
So, is Monday too soon
A test?
for the test?
Like Monday's fine. No, Monday's fine. On Thursday, or tomorrow on Zoom, I remember in 251, we would go over like, oh, we're gonna have this type of problem, this type of problem, this type of problem. Do we do that again?
Sure, I'll probably forget by then, so remind me.
That would be nice.
I gave you most of the long ones because I figured daisy chaining is gonna affect you more than me.
Okay,
I didn't know if you use these, I usually use banana plugs because,
I usually banana plugs.
yeah, so I think I gave you enough sets.
Okay,
Because I'm also gonna use them, so I'm trying to,
if we need more,
we will come first in and steal them.
I'll send some of my bodyguards down and take them.
My only concern about pushing the test out is not having enough respite between tests,
Yeah.
sort of deal, and just kind of getting burned out. So I don't really want to move the date.
I think the date's okay for me personally.
And then with like masters, like I did like half of master set 24 and realized it was due, like while I was halfway through it, and I was like,
I would like to see it.
Can we go over
I'll turn in the what I have.
can we go over the line of uniform charge distribution,
Line, uniform charge,
like with the particle out, but not in the middle?
Like off to
That
the
one?
side.
Yeah, now.
Oh.
Yeah.
well, the one in the middle is just twice that. So if you're doing the one in the middle, well, you've already done that problem right there. So you just do that and then double it. Recognizing that the vertical components will go away. 0 to some maximum value, and this is X naught. Subcharge negative P. Uniform distribution. My electric field's gonna be pointing in, well, that's my DY there. My electric field's gonna be pointing in that direction. Give me an example of what that direction, it's an angle that would be reasonable for what I've drawn there.
3 degrees,
Sorry,
30 degrees?
isn't 30 degrees that way?
No.
150 degrees?
Okay, for example. What about something going in that direction?
It's like
330 degrees.
270 and some change.
Okay.
270 answer.
There were a number of people who labeled this as, or that, as a 45-degree angle.
That's probably me.
Well,
I just said 30, so one
for doing like your triangle or whatever, if you only care about like the sign and whatever, is that okay? Just not on like an answer, but for like doing your own work, is that okay to make that angle?
Oh, I have no problem with you're doing your own work, but there was that part D, which was very set up of the direction of the electric field at this point, and where this is X of naught. And, you know, yes, there's a 45-degree angle in there, but if you tell me that the direction is 45 degrees, that's that way.
Oh, I think I remember that problem.
It's a second quadrant angle.
I think I just adjusted it afterwards.
So far, all the ones I've graded, everyone did 45 degrees.
Oh, never mind.
Yeah, I adjusted it and I didn't really tell you.
All right, so anyway, enough of that. So it's, I asked you, are you fine just finding the electric field there? I can't remember if I asked for the force of the electric field.
I think it's on the electric field.
All right, so the electric field's pointing in that direction. That distance there is R. I'm gonna come up with a fake angle of theta. Or temporary angle, probably better. It's a real angle. And I know the electric field at this point because of here. The electric field, well, it's actually the differential of the electric field because this is just a very tiny bit of charge here. It's gonna be K dq of negative R hat over R squared.
What is the negative R hat? That's saying that
This
it's
is the
20
charge that's creating the electric field. The negative R hat means it's pointing towards it. We're gonna put it in rectangular form in just a moment. But the fact that this is negative charge here means the electric field's pointing towards it.
Okay, that makes sense.
So we set up a traditional I hat, J hat. Oh, also, one other thing I found strange is that, and it's not inherently wrong, it's just, it threw me, of people who set up their X, Y axes on a different problem, where positive X was there and positive Y was down there. And it might have been just a matter of, they didn't give themselves enough room at the top of the page, so they decided, oh, let's make this the point, 0 to 15, but it threw me.
That was me, yeah.
There were 2 people actually did it.
Oh, really?
Yeah.
But you're right, it's just like, I drew the line, I initially thought it was gonna go in a different direction, looking at the problem, and then working at it, I was like, I gotta go down.
Okay.
There was enough space, and I just was too lazy just to rehash it.
I mean, it was defined, so it was a matter of, I got lazy and I skipped over that part, figuring it was the typical stuff, and then I thought, wait a second, it's got a sign off. And then I looked back up and go, oh, okay, now I see what it's done. All right, so in rectangular coordinates, well, I've got these 2 components right here. So the cosine is gonna be my horizontal component, my sine is gonna be my vertical component, where I've defined theta. And so it is negative K dq over R squared cosine theta I hat. And the negative is because it's going to the left. Plus K dq over R squared sine theta J hat. Now, in the master set problem, I asked first to find dE sub x and then dE sub y. And so this is the combination of the 2. And I also put a restriction on the final answer needs to be in terms of certain things. Theta is not one of the things on the list. So we need to now get this into other terms here. I know that if it's a uniform distribution there, well, lambda is gonna be Q over Y sub M, or negative Q. To be the Q dy. Have to think through that minus sign there for a second, because I'm potentially playing with two different definitions of Q, but I think I'm good with that. So dq would be negative lambda dy. So I can plug that up into here. So I have, so dE, just the x component, negative k, plug that in, negative lambda dy over r squared. Let's go ahead and cosine theta, that's adjacent over hypotenuse, that's x sub naught over r. And I hat. Well, the minus signs will cancel out. Again, r cubed down here. And I know that, well, that distance there is y, so r squared is equal to x naught squared plus y squared. So this becomes k lambda dy x sub naught over x naught squared plus y squared to the 3 halves. I hat. And the last little bit here is the fact that lambda also is a temporary variable. I didn't define lambda in the problem. Lambda is just some, as in the initial problem. Lambda is something I'm throwing in here just as a convenience, but I do need to make the substitution here. So I ultimately end up with negative k q x sub naught dy over x sub naught squared plus y squared to the 3 halves. And so that is the differential of the x component of my electric field. And so integration would be to actually find the x component as opposed to just a differential. Questions there before we tackle this one?
Where did you get the 3 halves at the bottom at?
I have an r squared here, and then I have an r here.
Okay.
And so r cubed. R is the square root of this.
Yeah. Okay.
And what did you, how did you go from lambda to, where did the k come from?
Oh, K is the electrostatic constant, Coulomb's law.
Or my bad, I meant q on the
Okay.
bottom.
All right, so the distribution is uniform. So it's either the charge over the length, or it can also be the differential. Since it's uniform, the ratio of charge to distance here is the same as for the entire thing.
Yeah.
And so at that point, I just substitute this part in for y, or sorry, lambda.
So why isn't there a q over
Ah,
ym?
because
Oh, okay.
I messed up.
Okay, thank you, sorry, I was confused by that.
No, thank you very much.
And y sub m is just y max?
Yeah, whatever that value is. All right, other questions before we tackle the other component?
Is it just gonna be the same thing if we use?
The difference, this is gonna be y over r instead of x sub naught over r. And everything else is the same. So what you end up with in the end there is, so DEY should be negative KQ y dy over ym x naught squared plus y squared to 3 halves. And I would contend that the I hat and J hat at this stage right here is optional because it's already implied that the Y component has to be vertical, but if the X component is horizontal. I think technically that should not be there, but need to make sure I haven't taken off of that. All right, so now it's a math problem. So E is the integral of dEx I hat plus J hat pulling out the constants, I got a negative KQ x sub naught over y sub m integral dy over x sub naught squared plus y squared to the 3 halves. And y is my single variable here, so I need to integrate from the smallest to the largest, so that would be from 0 to y sub m. Plus this bit, oops, that negative sign should not be there. KQ over y sub m integral from 0 to y sub m, y dy over x naught squared plus y squared to the 3 halves. Mathematically, you're doing U substitution here. This one, you're either looking up or doing trig substitution. The math involved here and the math involved here are two very distinct, different ways of doing integrals. But either way, there are things we've done already. So negative KQ. Was it y over x naught squared square root of x naught squared plus y squared? I'm going off memory on that one, which is never a good thing. Ooh,
Not a good thing.
I hat, J hat. And use substitution. I mean, at that point, it's I'm hoping you're comfortable enough.
Can we also use the table integrals?
Yeah.
Okay. Where do we find that? Is that
I don't know.
in the course? I looked it up when I did my master set.
I found a reference page on Blackboard, but I think it was on the supplemental information tab.
I got mine from my
The
calculus
one that you
course.
had for differential equations was really good.
Yeah.
All right,
That's
so in
cool.
terms of, let's say, Monday, and you suddenly are faced with an integral. There are certain ones, this one is given at the top of the first page. I think also to the 1/2 power is also given.
Oh, so you'll give us this on the test?
Yeah, well, this one I don't give because that's U substitution, and I figured that's easy, simple enough. But if you're faced with this and you're blanking because, you have test brain going on, just ask and I'll look it up and I'll write it on the board.
Okay, thank you.
And as always, if you wanna mess with other people's minds, ask them for something that you know is not on the test.
Is that something you do?
So, I mean, I know, yeah.
Something that we-
But the two things will happen. One, people will get that and go, oh, God, I can't believe he thinks you need that. Or they'll go, wait a second, where do I need that? So they'll take pity or they'll panic. Or if you're like me when I was in college, or my son, you wouldn't notice at all, so.
So kinda like the
So
same
something
thing,
written on the board.
same thing if we turn the test in super fast and we pity you or be concerned?
Yeah, yeah, pretty much the same thing.
Okay.
Other questions?
I remember one of my calculus exams, someone opened up the first page and then just shut it, just bubbled all the answers and turned it in.
I'm trusting it did not go well.
I don't know, I didn't ask her. I thought that was,
And then there are apocryphal stories of the philosophy class where it was one question, why? And people spent pages answering the question why philosophically, and somebody wrote, why not?
There you go.
Why not was good enough for an A.
man, I need to switch
I
majors.
don't, I don't know if the story's actually true or not, it's one of those legends.
Why not? Yeah, exactly.
I will say that the very first question on the very first test I ever gave as a teacher back in '86, I asked why.
And what were some of the responses you got?
Unfortunately,
I won't-
they were too young to understand the brilliance or the complexities of the question.
Oh, is that when you're teaching like high school?
Yeah, it was high school. All right, other questions?
We should probably get one for next school.
About you get what?
I'm thinking I probably should get to like a high school. But it's okay.
All right. The lab is the parallel plate